In this video, we will be learning how to graph the base sine function along with starting on our transformations knowledge. So to graph f at x equals sine x for the first time, we're going to do it with a table of values. So the x values in this table represent what we would be putting in for the angle, and your calculator should be in degree mode, and we would be typing in sine 0, and if we punch that into our calculator, we get 0. Sine 30, and we get 0.5. Sine 60, 0.87. Sine 90 is 1. If you're not getting these values in your calculator, then you're probably in the wrong mode, so make sure you're in degree mode. Continuing, sine 120 is 0.87. Sine 150 is 0.5. Sine 180, we're back to 0. Sine 210, we're now in the negatives, so 0.5. Sine 240, negative 0.87. Sine 270 is negative 1. Sine 300 is negative 0.87. Sine 330, negative 0.5. And sine 360, and we're back to 0. Now I'm going to go ahead and plot these points. So 0, 0. 30, and on my x-axis each box is 30, so 30, 0.5, 60, 0.87, so I'm pretty close to 1 but not quite. Then we're up at 1 at 90 degrees, then we're heading back down 0.87, 0.5, and back to 0. Then once I hit 210, I'm in the negatives, negative 0.87, negative 1, negative 0.87, negative 0.5, and back to 0. So one cycle is going to take 360 degrees, and it's going to form this wave shape. And this will continue on forever in this wave pattern. So let's fill in the table of values with some key properties by looking at this graph. So our key points. By key points, I mean the characteristic points that create this shape. So the maximum and the minimum definitely needed. And then I have 3 points on the x-axis that seem pretty important. So my key points will be 0, 0, so the origin, 90 at 1, 180, 0, 270 at the minimum of negative 1, and 360 back to 0. Our maximum value of this function is 1, and our minimum is negative 1. The domain, because this can go forever past 360 to the right, past 0 to the left, our domain is infinite. And our range goes from the minimum to the maximum, including those values. Now for the amplitude and the central axis, I'm just going to draw those in. So here's my central axis at 0 because my maximum was negative 1, or sorry, my minimum was negative 1, my maximum was 1, so right in the middle would be y equals 0. Then the amplitude is going to be my distance from max to midline or midline to minimum, and in both cases that amplitude is 1. The period is 1 full cycle, which is 360 degrees, and 360 degrees is a full rotation around your Cartesian grid. The y-intercept is at the origin, and the x-intercepts in one cycle are 0, 0, 180, 0, and 360, 0. There are actually an infinite number of x-intercepts because this graph does continue forever. So this is a great starting point for f at x equals sine x, but when we graph this, we're not going to do the table of values each time. So we're going to do a super quick graph one more time. The key thing we should have seen from the initial graph is that sine begins at 0 degrees, at 0, 0, the origin. And if we look at these key points that we have here, they occur every 90 degrees. And as long as you remember that they occur every 90 degrees, you just have to remember the general shape. Sine started at the origin, and then it headed up to its maximum. So 90 degrees later, I'm at the maximum. 90 degrees after that, I have to pass through the midline. 90 degrees after that, minimum. 90 degrees after that, back to the midline. And there's one cycle. But I can continue this. Add another 90 and another 90 and just follow that wave pattern. So I added a second cycle to the right, but I can also add one to the left. So continuing this wave pattern, I need to go down to the minimum, midline, maximum, midline. And there we are. There's my sine x parent function. Now that we have an idea for this parent function, we need to start transforming it. And the first transformation we're going to focus on is a vertical transformation, and it could be stretches, compressions, and or reflections. Now, the a value is what's going to give you these vertical stretches, compressions, and reflections. And if you think back to your knowledge of parabolas, you've already seen an a value related to a parabola, and the properties are the exact same. So if your a value is a value greater than 1 when you ignore the negative or the positive, so if the absolute value of a is greater than 1, you have a vertical stretch. And again, an absolute value just means whatever your number is, take the positive version. If the absolute value of a is less than 1, then you have a compression. And it's a reflection whenever a is less than 0, or in other words, when it is negative. So let's take a look at how we're going to graph this. So we're going to graph each function, we're going to state the transformation, the domain, range, period, and amplitude. So we are given y equals 2 sine x. The first thing I'm going to do before I even think about my transformation is graph the base function. So I start at the origin. After 90 degrees, I'm at the max, midline, minimum, midline. And I'm just going to do one cycle. That's enough. Okay, now if I'm graphing y equals 2 sine x, the 2, first of all, it's positive, so there's no reflection, and 2 is greater than 1, so it is a vertical stretch by a factor of 2. Now, it's not a rule that you have to memorize. Just think about if you were to multiply something by 2, would you make it bigger or smaller? You'd make it bigger, so it's a stretch. So what we're going to do, it's a vertical stretch, so vertical affects the y coordinate. Now the y coordinate of all the zeros is 0, so those aren't going anywhere. But my maximum has to be doubled. So my maximum is currently 1, it's going to be stretched to 2. And my minimum is going to be stretched down to -2. And here is our vertically stretched sinusoidal function. Now I can continue this pattern. I have to copy paste this. I know my key points are every 90 degrees. So 90 degrees later, I'll hop up to my new maximum, then my midline, then my new minimum, back to my midline. And I'll continue to the other side as well, down to the minimum and midline. That's all I can fit here. Okay, so my domain. My domain has not changed. My range has changed. Instead of the -1 to 1, we're now at -2 to 2, because that vertical stretch affected our maximum and minimum. My period is 360. That hasn't changed. And my amplitude is the distance from the maximum to the midline is 2. So the amplitude has changed. It actually looks like the amplitude is matching that a value. Let's see if that continues to happen. The next one, y equals negative sine x. Again, I'm going to quickly graph my base function. Every 90 degrees, I'm hopping to create this wave. Okay, now this negative just means a reflection over the x-axis. The negative is technically like a -1, so the negative tells me a reflection. The 1 is not a stretch or a compression, because if I multiply something by 1, I'm not changing that value at all. So we're just going to have a reflection. Now my reflection line is right here. It's the x-axis. So the points that are already on the x-axis, these ones here, they're not changing. The only points that change, again, are the max and mins. So when the maximum reflects, it's going to reflect down to -1. And when the minimum reflects, it's going to reflect up to the maximum of +1. And there it is. This blue function is -sine x. And I'm going to continue the pattern. So I'm going to hop 90 degrees to 450, and the logical continuation of this graph is down at the minimum, then the midline, maximum, midline. Continue, and arrow. Then same thing to the left, and there we are. Let's see what properties have changed. The domain is still infinite. The range is actually still -1 to 1. This time we didn't have a stretch or a compression, so the max and mins didn't change, they just flipped. My period is still 360, and my amplitude is a distance, so it's always a positive number. Okay, let's try another. 0.5x. So looking at the 0.5, it's not negative, so there's no reflection, but 0.5 is a number less than 1, so it should be a compression. Logically, think about what happens when you multiply something by 0.5. You make it smaller, so you're compressing it. So we have a vertical compression by a factor of 0.5, or a half. Forgot to draw my base function, so I'm going to do that quick. At this point, we should be getting pretty quick with the base functions. And now, again, the points on the x-axis are not changing. When I'm stretching and compressing vertically, I'm stretching or compressing towards or away from the x-axis. So if I'm already on the x-axis, where the y values are 0, a stretch or a compression will not move them. However, my maximum of 1 here, when I compress it by a half, it'll squish down to a half. And my minimum will squish to -1/2. And then I can connect my dots. And here is our sine function that has been compressed. And I'm going to continue my pattern here. It is going to be pretty squished, pretty close to the x-axis, everything, but that's because we've compressed. And there we are. Oops. So, domain, still infinite. Range has changed. Our minimum is now -0.5, our maximum +0.5. My period has not changed, my amplitude has. The distance, the new distance from the maximum to the midline is now 0.5. Again, matching that A value. Alright, last one. Y equals -3 sine x. Well, we have a negative, which means we're going to reflect over x-axis. We also have, so now that we've dealt with the negative, let's look at the 3. If I multiply something by 3, I'm making it bigger, so that means we have a vertical stretch by a factor of 3. So, base function, 0, 0, 90 at the maximum, 180, 0, 270 at the minimum, 360 at 0. Okay, I'm going to do this in 2 steps. First, I'm going to reflect. So my zeros are not changing. My maximum will reflect to -1, and my minimum to +1. Okay, now I need to stretch. Again, my zeros won't move anywhere because they're at 0, so stretching them won't impact them. But the -1 has to be vertically stretched by a factor of 3. So instead of being at -1, we're going to triple the distance. Triple the distance takes us to -3. We're technically just doing the y value of -1 times 3. Then I'm going to take the +1 times 3, takes me up to a maximum of +3. And there's our final graph. And I'm going to continue my pattern now. every 90 degrees, match the shape we just got. Now I could have done my reflection and my stretch all at once. So what I could have done is taken my original y value, so for example, this original maximum of 1, and multiplied it by -3. 1 times -3 would have taken me to -3 right away. And -1 times -3 would have taken me to my new maximum of +3 right away. Alright, properties. The domain is still infinite. The range has changed. It's now -3 to 3, kind of matching with the a value. The period is still 360, it's still going on forever, and my amplitude is 3. So, the observation we should be making to try to speed up our graphing is that the a value represents the amplitude. And at the moment, this amplitude is also matching up with our range, just the positive and negative version, but that's not always going to occur, so I'm not going to write that as a general observation. So for now, the a is the amplitude. And then what we should notice is when our a value was positive, from that origin point, we headed up to the maximum. But when our a value is negative, from that origin point, we head down to the minimum. So for example, in the example we just did, here's the origin, there was a reflection, so the final graph went to the minimum first. Whereas this number 3, 0.5 sine x, here's the start, we headed to the maximum. And that's because of the reflection piece. So let's just do 2 more examples here, and we're going to graph them a little quicker now that we have this observation. Alright, so I'm actually going to do my properties right away. I know my domain's not changing. It's always infinite, even for y equals 4 sine x. My period's not changing. It's 360. My amplitude should match the absolute value of my a value. So that's 4. And my range, well, if my amplitude is 4 and my central axis hasn't moved in any of the scenarios we've just done, my range should just be 4 below and 4 above. So when I graph, I know sine will begin at the origin, and the a value never affected that starting point. Now, if I know that my amplitude is 4, that means I'm going to have a maximum of 4 and a minimum of -4. And my central axis is still at 0. And now, the fact that every key point occurs 90 degrees apart, that never changed in the previous 4 examples. So I know my next key point will be at 90 degrees. Because there's no reflection, I should be heading up to my maximum. So at 90 degrees, I will be at 4 instead of the usual maximum of 1. 90 degrees after that, I need to pass through my midline. 90 degrees after that, I'm going to dip down to my new minimum of -4, and 90 degrees after that, back to the origin, and there's one complete rotation. And I can continue my pattern, of course. Just keep hopping every 90 degrees, and then backwards as well. And there's y equals 4 sine x, much quicker. I didn't have to draw my base function this time. I just jumped straight to drawing in my max and mins, and then drawing the pattern a little stretched in this case. Okay, next one. Y equals -1.5 sine x. The domain's not changing, the period's not changing. My amplitude, even though we have a negative, that just tells me that we're going to reflect. And because we're reflecting from my origin point, I'm expecting to go down and then up. So that's kind of the shape I'm expecting. But my amplitude is still a positive number, it's a distance. And if my amplitude is 1.5 and my central axis is the x-axis, that means my maximum should be at 1.5 and my minimum at -1.5. So that will give me my range before I've even graphed anything. And now, here's my starting point at the origin. And I've already said with the reflection, I should be heading down to the minimum. So 90 degrees later, instead of going to my new max, I'm going to go to my new min. 90 degrees after that, I have to pass through the midline. 90 after that, I'm at the maximum. And 90 after that, I'm back to my midline. And there's our first cycle. And now copy paste to create the rest of the function in both directions. Just following that pattern to have that nice wave. And there we go. That's it for graphing number 1, the base function of y equals sine x, starting at the origin and every 90 degrees, hopping up and down, the max, the midline, the minimum. And the minute you have an a value, that's going to affect your amplitude. And if it's negative, you'll add in a reflection as well. Now, if you prefer drawing in the base function first to visualize it better and then apply your stretch and compression and reflection like I did in the first 4 examples, you're more than welcome to do that. If you prefer this more efficient method of just identifying your max and mins with that stretch, compression, or reflection, go for it. Both methods are great.